So for this problem, we want to utilize a potential energy curve to determine forces and then the motion of a particle from the information we have in the curve. So then for our question, to show that we can determine the forces, my question is going to be, what is the force at x equals 9? And so this is going to be the potential energy curve. So then to figure that out, we know that the force is equal to the change in potential energy with respect to the change in position. So then that is essentially what our x and y axis are on our potential energy curve. So then we know that that's going to be equal to the slope of our line, and then is going to be equal to the negative force. So our force is going to be the negative slope of our line. And so we want to know at x equals 9. So then we'll go to that point right here. We'll find that part of the curve where it's straight, and then figure out that slope for that part. And so we're going to say that it's over 1.5. That's going to be our run, and then our rise is going to be, say, from 17 up to 23. That's going to be 6. So then we just put that change in y over our change in x, and then that's going to be equal to our negative force, which we get 4 newtons out. So then the second part of the problem, to show that we can determine the motion of the particle, is that we want to know at what point on this curve is the object stopping and changing direction, and when the kinetic energy is equal to 0. So we know we'll say this is given in our curve that k equals 0 across this line right here at about 20 joules. So then at each of these 3 points on the graph where the curve intersects that line, our object is going to stop at each point where k equals 0.